Okay, so we're now in section 4.4, and so today we are going to talk about evaluating trig functions of any angle, some more trig functions. We're going to talk about reference angles, and then we're also going to evaluate trig functions using reference angles. So this will be an alternate way than using the unit circle. All right, so in the past, we have used trig functions with acute angles only. So only angles less than 90 degrees unless we were using our unit circle. All right, so the question is, what if our angle is not acute? Can we still use triangles to measure our trig functions? And the answer is yes, we can, because if we have something, so if we have like an angle that is bigger than 90 degrees, so this would be our angle, we can still determine the trig function of our angle by using this triangle. All right, so this would be called a reference triangle. And we have a right triangle, and we know how to use trig functions with right triangles. Okay, what if we had an even bigger angle? So it opened all the way to somewhere in the third quadrant. So something like this. Well, we can still make a right triangle this way. All right, and even in the fourth quadrant, so if we start here, we end in the fourth quadrant, all right, so we're going around the positive direction, we can still make a right triangle. All right, so the point is, we don't just have to have acute angles, we can make acute angles, or we can make acute triangles. And use our triangle trig. All right, so let's say we have a circle with center 0, 0 and radius r. This is the equation of that circle, and we'll see it makes sense with the Pythagorean. When we choose a point x, y, we can create reference triangles inside of the circle to define our trig functions. All right, so first I am going to do an xy plane, and I am going to make a circle. All right, and this doesn't have to be a unit circle. All right, so the equation of any circle, but this circle particular, centered at the origin, is x squared plus y squared equals r squared. All right, so our prompt says we need to choose a point. You can choose it anywhere. I'm just going to choose it over here, x comma y. Here's our point. We can create reference triangles inside of our circle to define our trig functions. All right. So I can create a line going to the middle, which represents our radius. I can draw a line straight down to the x-axis, and that gives me a right triangle that is inside of our circle. All right, so in order to define our trig functions, we do need to figure out these side lengths, but we have this point here, right? This is an x value, all right? So that tells us the length of this side length, all right? So this would be our x value. This is the height, so it represents the y value. All right, and we can talk about any angle, but in particular, we like to talk about the central angle. And so now you should see how the equation of a circle works. X squared plus y squared equals r squared. We can make triangles inside of any circle. All right, so let's talk about our trig functions. If our point xy lies on the terminal side of an angle, the 6 trig functions can be defined as follows. Again, I know it seems like we're defining our trig functions in 1,000 ways. It's still the same. Sine is opposite over hypotenuse. Opposite side is y. Hypotenuse is r. All right. Cosine is x over r, so the adjacent side over the hypotenuse. Tangent is the opposite side over the adjacent side. So this is the same thing we've been doing all along, right? But now we're just working with points. And so this should look kind of similar. So what changes with this picture when we're on the unit circle? Well, when we're on the unit circle, the radius equals 1. And so that's why sine of theta is just y over 1, x over 1. All right, so it's the exact same definition. This time the radius is not equal to 1. Okay, let's do some examples. Number 1 says, let -6, 8 be a point on the terminal side of our angle, and we want to find each of the 6 trig functions of our angle. All right, so first, let's find our point. Let's draw an xy. I'm going to draw it over here to the side. Where would the point -6, 8 be located? Well, somewhere over here. So let's say this is our -6. Let's say this is our 8. So the point -6, 8 is located right here. All right, so this is a point on the terminal side of our angle. So let's draw a line here, here. This is our angle, theta. All right, so in order to determine our trig functions of this angle, we actually just need to make this triangle. All right, and so we're actually going to look at this angle, which is known as a reference angle, which we'll talk about more later. Okay, so we're going to use our trig functions and we're going to use this triangle. So we need to know all 3 side lengths of our triangle. All right, so here, this distance, you could either think about it as 6 or -6. We can keep with it being -6. The height is 8. How do we determine the other side, the radius? We can use the Pythagorean. 8 squared plus -6 squared equals the radius squared. Radius is always a positive number, so I don't have to worry about the negative. Radius is 10. Okay? All right, so now let's find our trig functions of that angle. All right, so sine of theta, we want opposite over hypotenuse. All right, cosine of theta, we want adjacent over hypotenuse. We want tangent of theta, opposite over adjacent. And then we want to take the reciprocals. All right, so we were able to find our trig functions of this angle using this reference triangle.